Before I start, I will say that a hacker in our industry, who's been a hacker in our industry for a good 20 plus years, Mike Kemp, otherwise known as Clappy Monkey, has been in hospital with an illness that is quite possibly life-threatening, and we're going to have a collection for him. So if you see a bucket with "Give money to Mike Kemp" written on it, then please give money to Mike Kemp, because, you know, could happen to any of us. Anyway, I am Kev, and my heroes are coming in to watch my talk. This is like in the front row, no less. This is quite scary. But at least this time I'm talking about stuff simpler and easier to understand than crypto. If I don't make sense, please shout out. We have a microphone, so you can ask questions, but let me know if I'm not making any sense. I am Kev Sheldrake. I'm going to be talking about exploits with Scratch. Here is the Who Am I slide to tell you who I am. Basically, I like crypto and I'm a hypnotist, so do listen to the sound of my voice. The talk is about how we can take a kid's programming language, literally the thing they teach in schools to 7-year-olds, and turn it into a hacking tool, or use it to make hacking tools. That's basically what this talk is all about. So if you're here for, Windows Active Directory exploits, you're probably in the wrong room. If you're here for random trolling that gets you a conference talk, you're in the right room. It kind of came about because I saw Travis Goodspeed at a conference, and I said, look what I've been doing in my spare time, and showed him some of the work on this. And he said, that's brilliant, I'll publish that in PoCs, get the fuck out. And if you look at this one, it's the Stack Smashing Academy for youngsters gifted and not. And the reason for that is because the second article, chapter 2, is Fun Memory Corruption Exploits for Kids with Scratch, which is my article on this. So I'm now published in the magazine that all my heroes are published in. Maybe not for the same reasons, but I am published, so hey. PoC or GTFO OX18 if you're looking. So let's talk about Scratch. I will make this more professional, honestly, I will make this more professional. Scratch is a language and an integrated development environment developed by MIT in 2003. 10 years later, they updated it and rewrote it in Flash, that famously great software environment, which weirdly enough in this situation does actually work, and they're now rewriting it again, and this time in HTML5 and JavaScript, which I'm sure will be far more whiz-bangy and sexy than the Flash version. I came into contact with it in the Flash version, Scratch 2, where you could add extra blocks. You could make your own procedures, which kind of extends it far beyond what you could do with it in Scratch 1. Normally, it's an online activity. So normally your kids will go to this website, scratch.mit.edu, and they just start scratching, which is the technical term for writing Scratch, in a web browser. But there was always an offline version available. So when my son, who's now 9, but when he graduated from Scratch Junior on the iPad, which wasn't very powerful and you couldn't really do much with it, but he graduated from that to real Scratch on an actual computer, running Arch Linux because I'm a sadist, I decided that the internet wasn't quite ready for him and protected the internet and all of you by proxy from my son by not giving him internet access. But that meant I had to give him the offline version of Scratch, and in doing so, discovered that Scratch actually will allow experimental HTTP extensions so that you could control robots, essentially. That's what they like to do with things like Scratch. That's the whole Raspberry Pi ecosystem is around, is like making stuff move, pretty much. Ignore the word experimental. It really does work. So before we go any further, we'll talk about Scratch. I'm not sure how clear this is. Maybe it is actually quite clear. Maybe you can actually sort of see that. This is a game I downloaded from the Scratch website. Everyone publishes their stuff. You can download. You can play it online. You can download the code. So I downloaded it just as a demonstration. I haven't written this. I don't know who wrote this. This is somebody else's code. What you can see there is a game in the top left corner. That's the application on the stage. This is a turtle moving around a maze. Down the middle, you can see the library of blocks that you can use, separated into 10 categories. We're looking at the motion category in this case. And on the right-hand side, you can see the code behind the turtle. So within Scratch, everything, the stage and all the sprites are basically objects. So behind the objects lives code. And it's completely object-oriented in that fashion, not in any other fashion, but in that fashion, it's object-oriented. And it's multi-threaded, everything happens at once, and message-driven. So you can pass messages between different bits of code to start and stop things happening. Which, it's got some quite grown-up things, but at the same time, you program it like it's basic, really. So if you look, the code on the right, you can see it's like jigsaw pieces. So you can only plug together things that should go together. So procedures, which are essentially the blocks, are like jigsaw, they can plug together. But when you need a predicate, like a true-false value, then it's got angle brackets on the end, and it'll only need to fit into a slot where there's angle brackets. If you need a value, it's got rounded ends, and it'll only fit into a slot where there's rounded ends. So you couldn't use a value where you needed a procedure, or a predicate where you needed a value, for example. It kind of constrains you in that sense to hopefully that you actually make code that is likely to run, even if it doesn't make sense. If we flick to the data section, you can see that there's a load of variables that have been defined. And two of those variables, apple count and coin count, happen to be global variables. But the fact they've got a tick next to them doesn't make them global. It just means that they're displayed on the screen. So in the stage, you can see the coin count and the apple count actually on the screen. That's what the tick means. But they do also happen to be global variables. The rest of the variables in that section are local to this sprite. So if I move on to another sprite, the maze, for example, it's got different variables. And if I cut between the two, you can see the variables change, but the apple count and coin count stay there because they're global. That's not what the tick means. The tick means it's on the screen, not that they're global, but they are global, those ones in this case. So each sprite has got its own code, its own variables, but you can share variables between all the things within the thing. Basically, variables can be global or local to a particular sprite, and the stage is like a sprite in this case, and blocks are all procedures. There are no functions, there's no return values, which if you're used to writing code in a normal modern language and not 1986 BASIC, then that's a bit weird, but that's kind of how it goes. And you can make your own blocks in Scratch too, and they are all procedures. There are no return values there. So you do everything through side effects. You basically have global variables or local variables to the sprite, and your procedure modifies the global variable. But obviously not while another bit of the procedure is modifying the global variable or reading from it, because everything happens at once and everything's event-driven and multi-threaded. So you end up needing state variables to know when to read global variables. Kids don't notice this because they're just too busy programming games. But like for those of us that care about how the programming languages work, it's a bit odd. But as I say, it works. So let's talk briefly about experiment HTTP extensions. Oh, this is Scratchy, by the way, or the Scratch Cat. Yeah, they didn't really give him a proper name, but Scratchy seems to be what the kids call him. And I'm down with the kids, as you well know. Normally, when you click the file menu, you get this menu on the left. But if you shift-click it, you get the super secret file menu, which gives you extra options, one of which is import experimental HTTP extension. And that lets you into this world where you can extend Scratch to do other things. The way it works is you run a web server on your local host, only on your local host. There is no IP address or host name within the spec. It's only a port number. And that's published through a S2E file, Scratch to extension, which you load in when you do that import experiment HTTP extension. And then from there onwards, it adds blocks. And then when you use those blocks, it runs those as procedures against that web server. And the web server does the stuff that you've asked it to do. But the web server also exposes variables, essentially global variables for that extension. And they are polled 30 times a second over a web API. Yes, 30 times a second. It seems insane, and it kind of is. But so far, it's never bitten me on the ass. So you generally use it like this. You generally invoke procedures that do things. They affect global variables within the extension, and you poll those 30 times a second and use those in your code to stop your code doing stuff when they change. I mean, this entire architecture is built for things like robot arms, right? Robot arms make perfect sense. Like, if you want to move a robot arm, move a motor, there's no feedback, there's no return value. It's simply move the motor by a certain number of degrees. But then there's also things like limit switches, like if you crash into a limit, and you want to know if you've crashed into a limit pretty soon, hence the polling 30 times a second. So this is kind of what it's built for. Right? I guess that kind of makes some sort of sense. Clearly not to the two people that just left, because they're thinking, this should be a hacking talk. He's too busy talking about Scratch and robot arms. And they have left one slide too early. Same for you. Because I thought, what if you replaced that robot arm control with TCP/IP sockets? Could you not open a socket and write to a socket and read from a socket? Of course, when you read from a socket, because these are procedures and not functions, there's no return value. You can't go read from socket and get the value back. You have to go read from socket and then poll a state variable until the state variable is changed to say that the data is now in a buffer, and then read the data from the buffer that's been affected as a global variable. I mean, it's not straightforward, but would that work as a system? Yes, is the answer. So the easy way to implement this is through the Python blockx module, which is available on GitHub. It's technically deprecated. They've got lots of messages on their site saying don't use it, but ignore that. It all works. I wouldn't install it from a Linux distro. I would go to the GitHub and clone it or download it and install it using the setup.py, because I've had all sorts of problems installing it from a distro, Arch, Debian, etc. But if you actually just get the Python in, just sudo Python setup.py install, it just installs and it just works, right? So the fact it's deprecated, not a problem. They link to a tutorial that actually explains how it works, as in up-to-date advice, linking to the actual API definitions, which is more than enough information to do this kind of stuff. And what you end up writing is something like this. So this would be your Python script. Obviously, at the top, we import blockx module. The green bit, where you define a class of functions, right? And so some of those functions will be procedures, which don't have a return value, but they do stuff. And some of those functions will be things that return the value of a global variable, a Python variable, from within the class. Then in yellow, we create a descriptor, which is from the module, which basically names it, gives it a port, tells it what blocks you're going to provide, and the menus, which provide the drop-down menus within the blocks, right? And then the next line in white joins the class to the descriptor, and the last line runs it. It's as simple as that. And to show you how simple it is, I have an example using say. And obviously, if you have a Mac, you know say, because you can make your computer talk, especially if you have a Mac that you can log into remotely, and you log into it remotely and make it talk to somebody else when they're not expecting it. So the class for Scratch say is literally this. It's kind of like, it has one function, one procedure, which is say, right? And the block definition is kind of like this, which is a simple description. Basically, the block is say a message, %s is replaced with a message that you type in. With voice, %m.voices. %m is replaced with menus. So basically, in the block description, you can have %s, where a user could provide a string, %n, where they could provide a number, and %m dot the name of a menu, where you can provide the details for a drop-down menu. So you can constrain what they can put in that particular one. And you also provide the menus as a dictionary, and that creates a little bit of script, basically greps up all of the English voices that say can use and sticks them into a list, which is then used. So the whole example for making your Scratch program be able to speak from a Mac is that. That is the entire Python script using that module. It's very, very simple. When you run it up, it sits on the port that you've told it, port 5000, so you browse to that, and it literally lets you download the Scratch 2 extension or the Snap blocks extension. I don't use Snap, I only use Scratch, but you can download it from there. You get the S2E file, which is the thing you load into Scratch using the import experimental extensions menu item. the file looks like this. It's just JSON. I mean, obviously, it hasn't got the spaces. I mean, I've pre-printed that. But, like, it's basically... So the menu is a list of all the voices, the port, the block, the name. You know, it's pretty simple. So we'll do a quick demo. This is the test to see if I am sober enough to do demos. Because if not, I've got screenshots and we can skip the entire proper demo. But we're going to try and do a demo. Right. This is like... I can do this. I tell you I can do this. Okay, I've called it speak. Right, so that's going to listen on port 5000. Now, we need to go and use Scratch. It's like you can either look under the lectern at the screen or you can like look at this one. Neither is actually useful. So what we're going to do is import the extension. So I'll shift-click this. And now if I go to more blocks, we now have a new block, which is to speak out loud, say, okay? So we'll create a quick, this demo is the shortest thing in the world. And if you're waiting for the hacking bit, don't worry, it's coming. So when I press the space bar, say something, and that something will be... So,
please give generously, you bastards.
So now you can make your Scratch speak through the wonders of Python and blockx, right? So that's just to show that the extension works, like the module works. It's as simple as that. With that tiny one-page amount of Python, we can extend Python. We can extend Scratch, sorry. So if we cut back to the slides. So, Scratch sockets. I created a class which can do these kind of things. This isn't the full list. Like, it's hard to fit it on a slide, but these are the kind of things I added, like create socket, write socket, recv socket, readline socket, etc. And I've actually got the Python for some of these functions just to show you how simple it is. But basically, create socket literally uses s.connect to create a socket. Write socket takes your data, encodes it decodes it from the format that you've given it, because Scratch has no binary formats, right? So if you want to send bytes beyond the ASCII range, you need some kind of encoding. So I've built in like base64, URL encoding, C encoding, etc. Right? So Python just decodes that and then chucks it out with a socket.send essentially. Equally, if you want to receive, it uses socket.receive and chucks it into a buffer. It's got some flags in order to say if it's still reading, if it's finished reading, if the socket's dead, that sort of thing. And then read buff, which actually reads the buffer of the stuff that you've just recfeed, will encode it in the format that you want to encode it in so that Scratch can actually deal with it. Because obviously, like I say, it's got no binary type. So if you've read binary data, you need to encode it with like URL or base64 or C encoding or something along those lines. The descriptor for it looks a bit like this. It's called Scratch Socket. It's port 5000. We have blocks. This is just one of the blocks, but there'd be a block for every function you could do. So the create socket is a command block, which means it's a procedure. And it's create proto as a drop-down menu, connection to socket number as a menu. I was going to use file descriptors, but I thought that was probably overkill. Like, who really needs more than 5 sockets when you're writing an exploit? If you need more than 5, you can extend it easily, but like, really, so make that a drop-down to simplify things. The host name is a string, the port number is a number, there's defaults for that. And it gives you a block that looks a bit like that. So literally, in Scratch, you can create TCP connections. I mean, Scratch is a sandboxed environment. You're not supposed to be able to break out of it and do nasty things. For all those nefarious 7-year-old hackers, you're not supposed to be able to talk to other people's computers. But, using this, you kind of can. And then I have a dictionary with menus for like the types of encoding, the protocols, etc. So when you've loaded those blocks into Scratch, when you've installed the extension, you get all of these blocks into more blocks. And some of them are procedures, which are the ones in like jigsaw pieces. We've got predicates, we've got angle brackets, and we've got values, which are the things that we've returned, which also include state variables. So let's hack. What we're going to hack today, so Scratch talks to a web server which is running BlockX, which is on the local host, and then it goes onwards to talk to another machine. And that other machine is tinysploit from Saumil Shah of NetSquare. This is part of his exploit lab. It's tinysploit 1. You can get it. Spoiler alert, I will be hacking it. If you are going to hack it yourself, then I might be giving away how you want to do that. Shall we do the demo? It's only 10 past 8. I'm technically here for another 20 minutes, so I think we should try and do it live, which is hilarious when you think about it. That is tinysploit. It's time for... What is that in my beer? Someone's cigarette ash or something. Never ever hack sober. Right. So tinysploit. You log in. If we type PS, we can see there's processes running. The one we care about is the HTTPD. We can see that there's a web server listed on port 80. That's what we're going to connect to. So the first thing we'll do is set GDB on it, 711. And then in Scratch, where's my mouse pointer gone? Where is my mouse pointer? Ah, okay. Right. So the first thing we want to do is crash it, yeah? Because, like, you know, where else do you start if you do? It's a stack smash, right? I'll let you in for a secret. If you're going to crash tinysploit, it's a stack smash, right? So the first thing we're going to do is crash it. Can you read this, or do I need to make it bigger? Bigger would be better. Can anyone remember how to like zoom a Mac? No. Control Alt plus. Right, so is that better? Yeah? Yes? Yeah. Okay, so this is all of the Scratch code to crash it. Basically, you would fuzz it normally. You'd normally guess the length as being like 10, 20, 30, 40, 50, and wait until it crashes. But I guessed 2,000 because I'm a bit cavalier and lazy, and it works at 2,000. So I created my own procedure here in the more blocks section. In fact, I'll click on it, I'll show you. More blocks. I made a block using make a block called create a buff, and here's this create a buff. And all that does is sets the a buff to the number of capital A's that is equal to size, which we call it with. All right, so I wanted 2,000 A's, I've got 2,000 A's, and then I set my data buffer to get slash 2,000 A's, followed by http:/1.0/n/n, and then I'm going to make a connection to a host, 102, and it's on port 80, clearly. And then it waits until that socket's connected, because, you know, who knows how long that will take. It writes it as a C-encoded string, because, you know, when we start doing exploiting, we'll need to be C-encoded. Waits for a couple of seconds, and then quits. So if I zip that back down, in this window here, you'll see what I send, and in this window here, you'll see it crash if I've done it correctly. So I'm going to hit space, Did not go. It did not go. For what? Slightly concerned. What's happened over here? Was it not 102? Or did I miss that? Read that. This is a bonus demo that is not going to work, clearly. Somewhere I checked the IP address. Okay, right. We can do this. It will work. 56.102, right. So, if anyone spots my obvious error, then do shout out what it is. That's the right IP address. That should be able to see it. Okay, that is the right IP address. Port 80, sounds about right. So what was going on in this window here? Oh. Why can't I cut out of that? Okay, this is making me look super professional. I do apologise. Right. You shift load it in, but that's already got it loaded in. That would normally work. Create that. It says for. Oh, I've got the wrong extension loaded. I've got the wrong one in this window. That's what it is. Right. We'll be fine. Right. Switch into what? Mirrored. It'll be fine. Honestly. Right, we have the right extension loaded. Well done, Tim. Buy Tim a beer, someone. Right. So, we'll reconnect to that process. Right. In Scratch, we'll now hit stop, obviously. Stop. Right. Loads of A's. Process crashed at 41414141. Right, so we've actually sent a packet to the web server and it has crashed with 41414141, which is obviously 4 capital A's. Right, so we're in business, aren't we? Yeah? So the next thing we want to do is we know that we can overwrite EIP with something in our buffer. So we want to know where in our buffer we're overwriting it. So the next thing to do, oops, not save. Okay, save if you want. The next thing we do is we want to find where that is in memory. So we create an enormous amount of code. So Scratch doesn't have hexadecimal numbers, and it doesn't also have a ASCII to hexadecimal conversion or a decimal to hexadecimal conversion, which is really annoying. So you have to write your own. So a lot of these functions here, this is creating a pattern, a non-repeating pattern, very much like MSF pattern.rb, which will create 30-odd K's worth of non-repeating pattern data, like triplets of like capital letter, lowercase letter, number. But when you send it, when you try and look it up, you've actually got to take your hex number and convert it back to ASCII somehow, and that involves writing a whole load of Scratch to do that, which is what I've done there. But basically, whoa, don't break shit. He's right. The man who said you should mirror your display was actually correct. But anyway, regardless, so if we find this, we just need to fill in the host and the port number. And then we can send our pattern buffer instead. So instead of sending 2,000 A's, we're going to send a pattern buffer that's 2,000 characters long, which does not repeat ever within that 2,000 characters. So are we connected to GDB again? No, we're not. Let's reconnect to GDB. We're now going to crash it again, but this time we're going to crash it in spectacular fashion. So hit space. Here you can see a non-repeating pattern buffer. Yeah? Over here, we can see it's crashed at 6C41376C, right? Which is, and if we were to examine the top of the stack, we've got a value for the top of the stack, right? So what we want to do is look those up. So maybe we can move this. No, we can't move that. 6C41376C. Can we all remember that? 6C41. Anyone remember? 376. 6C4. 376C. Yeah? 376C. Location 352. So we should write that down. If anyone's got a pen and a piece of paper. This is how live the demo is. We actually need to make notes as we go. So location is 352. I feel like a magician right now. Oh, has anyone got a pen that works? This will go down in history in 44con's lexicon. 352, right, okay. Now we'll do the same thing. And this time we want to know like what's on the top of the stack, right? So 396C, 4138. 396C, 396C, 4138. Position 356, which as you might notice is 4 bytes after the 352. That means if we put a value at location 352 in the buffer, that will end up in our instruction pointer. That's where code's going to continue to execute from. And position 356, which is literally after it in the buffer, is the top of the stack. So if we could put our shellcode at the top of the stack and somehow we could jump to the top of the stack at position 356, we would have executing shellcode. So in order to do that, we probably want to find a jump ESP instruction within the binary, right? Well, obviously it's got a link to libc there. I think it's got a link to libc. Yeah. That looks remarkably different to what it did the other day. But anyway, so we'll quickly search libc B7EC5000 OX B7FD C000. Anyone remember what a jump ESP instruction is? Is it OXE4? No, I can't type. Oh, I needed a comma. No, don't do this when you've been drinking Guinness. Is it there? Yes. And there's loads of jump ESP instructions. So we'll write down the first one, which is OX B7EC7A51. So basically, they are all jump ESP instructions. If we could land our execution, our instruction pointer on one of those, it would execute the instruction jump ESP. It would jump to the stack pointer, and the stack pointer will contain our shellcode. It will run our shellcode. Stuff will happen. No NOP sleds required. Literally, return to libc a la 1995. It will work, right? This VM has no protections. There's no NX or ASLR or any stack canaries or anything clever. So we could then probably, where's my mouse pointer? Has anyone see the mouse pointer? There's the mouse pointer. Right. So let's kind of do that. Let's do it. I'm excited, even if you're not excited. So I wrote an exploit, because I like writing exploits, and I find that Scratch is the easiest language to write exploits in. It's less than Python, and it's definitely less than C, right? I mean, all of that stuff there is literally sticking 8 bytes at a time into a shellcode variable, only so it fits on the screen. You could do it all in one line. It really is that simple, right? That's the shellcode. So that came from exploit.db, Julian Ahrens. It would normally be the shellcode that runs /bin/sh, right, with no argv or np arguments, right, just a null for each of them. But of course that doesn't work because our target environment, tinysploit, is busybox, and busybox is a multi-use binary, and therefore it needs an argv 0 value, which is actually /bin/sh or something along those lines in order to work. So I had to actually modify the shellcode. So there's more work that's gone into this. Come to my workshop tomorrow at 1:30 to 3:30 if you want to learn a bit more about how to modify shellcode so that it works in BusyBox environments and not just in like normal like other people's Linux environments. In fact, come to the workshop anyway. It'll be the most fun thing you've done all weekend. We will not only do another stack smash, we will do a format string vulnerability where we'll be bouncing off got plot in order to get our shellcode to work. It will be excellent fun. I know James Forshaw is running a proper workshop at the same time, but don't go to that. Come to this. This is far more interesting and exciting. So that sets the shellcode variable. This thing creates a NOP buffer. So it's like the A buffer thing before, except it's OX90, so they're all NOPs. If you don't know what a NOP is, it's basically a no operation. It's a single byte machine code instruction that does nothing. You can have as many as you want of them. It just fills the thing up. I could have used A's, I used NOPs instead. And all this is going to do, we're going to set here, so the EIP location is going to be 352 that we made a note of. The jump ESP address in little endian format is going to be /x51/x7a/x/ec/x_b7. Anyone point out if that is not correct? Because clearly we'll just crash it and not actually get shellcode if that's wrong. And then it's going to tag that in. It's going to create 352 NOPs. It's going to follow it with the jump ESP address, which is going to be the return address that is going to end up in EIP, which is where it's going to land on, which is then it's going to jump to the stack pointer, which is then going to be here, which is going to be followed by shellcode, which is then going to be followed by a number of NOPs to make the buffer 2,000 bytes long, because that's what we crashed it with originally, because who knows what would happen if we didn't do that. It might not get to this particular point in the process execution, and therefore it might not actually crash it the way we think it should crash it. That's what that's for. And then we and then we tag HTTP/1.0/n/n because it is a valid HTTP1 GET request that we're doing. And we are going to fill in the host IP address. How many dots have I got in there? 192. I did have two. Right. 168.56.102 on port number 80. And then it's going to wait, and then it's going to send it. All right. So in here, you'll see it go flying by, and in here we'll see magic. Right. So if I do a netstat minus plan to, oh sorry, I can't spell. Clearly I can't type. I can spell. I just can't type. There we go, right. So we've got 4 ports listing at the moment, 32001, 32002, port 80, which we're going to trash, port 22, which is SSH. So let's fire it and see what gives. Oh, God, I keep losing my mouse pointer. There we go, there's the mouse pointer, right. So I hit space. Did I hit space? I thought I hit space. Yeah, okay, right. So in this window here, if I scroll back, right. Oh, it did it twice. Yeah, who cares? Right, there's a load of NOPs to get us all the way to where the return address needs to be. So in here, it will be the return address followed by a load of shellcode, and then here will be a load of NOPs to make our buffer up to the bytes long. Over here, segfault. Motherfucker. That should not have happened, clearly. But it's only because I ran it twice. Right, so the first time I ran it, it probably worked. Because look, there is now another port listening, 1337, which is what my shellcode has launched, because clearly 1337 is going to be the port. Now, normally, if you were a hacker, you'd now get out your netcat, and you would netcat to port 1337 and expect to be root. Yeah? That's normally what you'd do, right? But we're in the world of Scratch. We don't have netcat. You know, we're not in a Linux environment, we're in Scratch. So, where's my mouse pointer? So what we need to do, and this might seem a bit complicated to understand, but we need to somehow connect to that port. So I wrote a console, which is basically netcat in Scratch. And it's that long. And the bottom right one is only if you want to strip off the carriage returns, which you may or may not need, depending if you're running on Mac or Linux. In this case, we do need them because we're running on Mac. So really, I need to add a strip statement, strip in here. So when we receive stuff, we need to strip it. And then we need to add stripped data to the thing. Right, we need to put in the host, which we'll do now before I explain any further. 168.56.102 on port number 1337. Hang on. 1337, yeah? And then we'll make this screen here a little bit bigger, like, because that, for some reason, like, ends up being the wrong size. So this is a list item, and I'm basically abusing a list item as my console output for full-on 1990. So if I hit space, this will run the program, and I get a prompt. And the obvious thing to type at this point is ID. And I'm there logged in. So, you know, we could do like uname -a, and we're running on tinysploit. And that is an exploit working in Scratch. Oh, not bin, yeah, slash bin slash busybox, obviously. So yeah, busybox. So we could probably sue at this point. Maybe, I don't know. Oh, it's gone beyond the thing. Hang on, let's just pull it up a bit. Pull that down. Oh look, we're now root because I sued, right? Because I happen to know the password. That's not a privilege escalation. That's because I knew the password, right? But it does mean I can probably turn it off to finish my demo. And there it goes. So we did actually get on the box and we did run root. So now cut back to the slides. That was the demo. So these are. Where's my mouse pointer? So these are the slides of what we did. So basically, we created a buffer of loads of A's, we sent it through, and it crashed the thing at 41414141. We then created a pattern buffer with a whole load of Scratch, which we sent through, and when it crashed at a unique value, which we could then look up with a unique value on the top of the stack, and a whole load of jump PSP instructions in libc, so we could do a return to libc trampoline, essentially. Scratch asked us what the value was and told us it's 352, and we asked it about the one on the top of the stack, and it's 356. So we created a bit of shellcode that looks like this. We had a whole load of NOPs. We had the return address, followed by some shellcode, followed by some more NOPs to finish off the buffer, so that at least it was the right size to make sure we crashed in the right point and not any other point. And then we created an exploit with actual shellcode, and we sent it through. And so before we sent it, there was no leaked port listening. And then we sent it through, and there was like a whole load of NOPs that got us to the point where we had to put in the return address. And then we put in the return address a load of shellcode. And when we sent it through, we actually had a port listening on 1337. And so hang on. We created a console, which was like netcat, and we had code execution. So you might be asking, why bother? And I'd kind of say the same to anybody else talking at these kind of conferences. Like, why care? Well, what is the point? Well, for me, it was a load of fun. It was kind of a troll that got out of hand, but it was just fun. Why not do this sort of stuff for fun? I mean, to put it into real terms, there are code clubs and there are cyber academies for kids, and they're all about making stuff and defending stuff, as if the only thing interesting and useful in the world is making more software and defending it so that it works. Well, I wasn't one of those kids, and there are probably kids that actually just want to break stuff. Like, I mean, I had a ZX Spectrum, and I learned BASIC on it, and I learned Z80 machine code so I could get infinite lives, which is essentially hacking games. I mean, obviously, you know, copy protection, yada, yada. But, like, the next thing I learned after Z80 was 8086 machine code, and I started my journey, which ended up turning Scratch into a hacking tool. But not all kids want to make stuff. some of them just want to take things apart and know how they work, and maybe there is a career for them in that. So I think it's a good idea, and perhaps in the world of cute, fluffy introductions to computers and cyber, perhaps we need something a little bit more scary. Does anyone have any questions, apart from how do magnets work? Because I don't know. There is a microphone here, if not there. There is a microphone there. Wait for the microphone. The microphone is coming. Do not speak into...
How long? How long? How long? How long is it going to take you to do that?
How long?
Yeah.
So, the question was, how long did it take me to do that? How many weekends
did you not spend with your wife and kids to do that?
Yeah, exactly. How long did it take? Well, it was about half an hour of Googling to find that you could make an extension and that there was a Python module to make the extension. It was about an hour of reading the tutorial on their GitHub and to understand it, to know actually that's perfectly achievable. It's not really that complicated. And then it was, I don't know, 20 minutes to prove it and the rest of an hour to actually make that actual extension. That extension's not even been modified since the time I wrote it. It's as simple as that. It took longer to write the talk and build the demo than it did to... And the first thing I exploited was a virtual machine that I can't actually show you. It was somebody else's project. So I've actually had to redo all of that on Saumil Shah's exploit lab. But yeah, like 2 hours tops to get to that point. I spent longer making Scratch talk to MIDI instruments and Lego power functions. And Lego power functions are exceptionally fun, right? You can, the demos I could show with Lego power functions. I mean, if there's not another question, or while you're getting the microphone to another question, do you want to see what we do with Lego? Right. Let's have a look if I can find some Lego. That was the hold music. So I gave a talk at EMF Camp last weekend. If you've ever been to EMF Camp, go to EMF Camp. It's brilliant fun. I made a ring. It charged me a lot of money, but I made my own ring out of silver, no less. And gave a couple of talks there. It was really good fun. I've been 3 times. Like, honestly, it's like Butlins meets Breaking Bad. That's the only way to describe it. Lego Power, I gave a talk about all the sorts of weird stuff we've done with Scratch. And this is like Lego. So my son made a sea monster ride for a theme park, which is programmed in Scratch. Obviously, it doesn't do a lot. It just like moves up and down, but it's kind of cool. And that's the box it's basically an Arduino that kind of does the infrared. But this is the one I'm proud of. So basically what happened was he said, can you make a thing so we can control our Lego motors? And I was like, yeah. And I went away and did that, and it took ages. And then he forgot about it, and he didn't care, and he was too busy playing Minecraft. And then one day he was like, Dad, have you got that thing that like controls Lego motors? And I was like, yes, of course I have. And I went round, and this is what he'd built: a remote-controlled crossbow. Which basically elevates itself to a random elevation and then fires a bolt at whoever is looking at it. If we had one more motor, it would be rotating. And if we had sensors, it would find you. I mean, it's like... I just like the fact it's got police on the side. It's like this, forget RoboCop. Like, this is the future of law enforcement, But yeah, so it's the sort of silly stuff we do with Lego. He's just moved on to Mindstorm, so Anyway, any other questions? I mean, it's 20:37. I've still got time for questions. I'm sure 44 Connor administration will say, no, your questions should have ended by now. So ask another question, someone. Any questions? Yes, I am drinking Guinness. I will be in the bar. I can answer all of your other questions there. There's another question. Wait for the microphone. Do not speak until the microphone arrives. I've been told the microphone will arrive. There's the microphone. Does it work?
Thank you for...
Oh, hello?
Hello.
Yes.
Thank you for presenting tonight. Can you just go back one slide? Yeah, that's what I want to read, that one. That's my question.
Can I go back one slide? Yes, I can. Keynote on the Mac does go backwards. Shall we call it there? Unless anybody wants to know anything, So give generously to the Mike Kemp Fund. He is a hacker and he's ill, and I think we should chuck some cash his way to help him out. And tomorrow, between 1:30 and 3:30, I'm running a workshop where we will teach you how to do a stack smash and a format string vulnerability using Scratch, and then at the end of it, we'll teach you how to do it in Python and C. So obviously, this is only for environments that don't have any modern protections like NX, ASLR, stack canaries, etc., right? But if you've never written a stack smash or you've never written a format string vulnerability and you would like to, and you would like to know how it's done, so to save you from like 6 hours of Googling, come and spend 2 hours in the company of myself and Tim Todd, and we'll show you how to do it. It'll be so much fun. You'll be able to go to the next conference saying, I can write a format string vulnerability. I've done it. And if you haven't done it and you can't do it, then shame on you. Come to the workshop. Thank you very much.